Hello coders, welcome to our YouTube channel Level Up with Coding. Today I'll be discussing the Leetcode daily challenge problem number 41. This is first missing positive, and let's understand what the problem is saying and then go to the solution part. Let's understand what the problem states. Basically the problem state you have a given an array of integers and you have to find what is the smallest missing positive number. Like for the first input that is given 1 2 0 and output is 3 because the smallest positive missing integer is 3. Like the first smallest integer is 1, positive integer is 1, and 1 is also present in my array. Then the next element is 2 is also present in my array, but the next element is 3 which is not present in my array, so basically the answer is 3. So for that case the answer is 3. Let's go the second example. So what is the first smallest positive number? 1. I see that 1 is present in my array. What is the next smallest number? 2. But 2 is not present in my array, right? So what is 2 is my answer for that case, and I see that 2 is my answer. Let's go to the third example. What is the first smallest positive integer? 1. But 1 is not present in my array, so 1 is my answer. Yes. But what about if that is -1 0 2 3 1? For that case 1 is my first smallest positive integer, but it is present in my array. Then 2 is also present in my array, 3 is also present in my array, and I'll go the 4, but 4 is not present in my array. For that case 4 will be my answer, right? Let's take another example. Like if I have an array and the elements of the array 1 to 3, right? So what is the first smallest positive integer? 1, right? But 1 is present in my array. 1 is present in my array, so 1 can't be my smallest missing positive integer, right? So I'll go 2 because after 1 the 2 is the next number, but I see that 2 is also present, right? So 2 can't be my answer. Then I'll go 3, but 3 is also present in my array, so 3 can't be my answer, right? Then I'll go 4, but 4 is not present in my array, so the answer is 4, right? For that case the answer will be 4. I think the problem is now clear to you, right? Okay, let's go to how to approach the problem, right? So I can first think about what is the brute force approach for the problem, right? The brute force approach of the problem is that I'll go through all the numbers, right? I'll go through all the numbers, I check if it is present or not. Like I'll start from the first positive integer, like 1, then I'll continue the process. Like I'll check 1 is present or not, 1 is present or not. If it is not present, that means this is the smallest missing positive integer and this is the answer. But if it is present, then I will go 2 and check, is this present in array? If it is present, then I will go 3, but if it is not present, then I can say that this is my one of the answer, right? By this process we can continue and we can definitely find a solution where the element will be not present in my array, right? And what is the constraint for the problem? Constant for the problem is 10 to the power 5, so I can start with 1 and go till 10 to the power 5 plus 1, right? Because in worst case it may happen if I am n is 3 it may happen that all the element starting from 1 to 3 are present in my array. So 1 is also present, 2 is present, 3 is present, 4 is not present. So I'll iterate from 1 to n plus 1, right? And I'll check that if my current element is present or not in my array. If present, that means this is not my answer. Then I will go to the next element, and if not present, that means this is my answer, right? So what I am doing, I will continue a loop I, which is start from 1 and go till n plus 1, and then I will checking if I is present in my array or not, if I is in array or not. If I is in error, then I can say this is not my answer, then I will go for the next element like I plus 1. But if I is not in error, that means this is my answer, else I'll return I, like for I is my answer. What I am doing, I am simply start from 1 and go till n plus 1, and for every I will checking that is it present or not in array. Like for checking in array, like there is an element like 1 2 3 4 5. For checking a element is present in array or not, this will take a element is present or not, it will take big of n, because I will do a linear search and I will iterate through I to n plus 1. I will iterate through I to n plus 1. It is also take big of n. So for that case, the time complexity will be big of n square, right? So I have to think about an optimal, right? But I'm seeing that I have to found whether a element is present or not in my array. So I can use a set, like if there are an element like 2 3 0 1 5, I can use a set and I add all the element in my set, like in a set. Then I will iterate through 1 to n plus 1, and then I will be check that if my I is present in array or not. Like the same approach, but as I am using a set, I can find it in log n time, right? I can find it in log n time. So using set, I can reduce my time complexity from big O of n squared to big O of n log n, right? Like for that case, the time complexity will be big O of n log n, but I am using a space. I am using a set, so the space complexity will be big O of n, right? So I have to think about another optimal approach, right? So what I am thinking, that as I have to find whether a element is present or not in my array, right? This is the approach, right? So what is the another approach? What is the another approach can be? An example first, and then try to understand what will be the next approach, right? Like first take an example, like I have given an element 5 4 3 1 0, right? So what is the first missing number? 1, right? So in the previous case, what I am doing that I will start from 1 and I will go till n plus 1, and I will be checking if my current I between I to n plus 1, that is it present in my array or not. If this is present, I will go for I'll go for the next type. If this is not present, then I can say that my current I is my answer, right? I is my answer. This is the previous approach. So what I'm thinking right now, that what is the first smallest, so what is the first smallest positive number? 1. What is the next number? 2, then 3, then 4, then 5. Look at the sequence. 1 is present in which index? 0 index, right? 2 is present is which index? 1 index. 3 is present is which index? 2. For 4 it is in 3. For 5 it is in 4, right? So what I will be trying to put a number, or I will be trying to put a number on its correct position. For 1 the correct position is 0. For 2 the correct position is 1. For 3 the correct position is 2. Such that, right? What I will be doing, I will be try to rearrange my array in such a way such that every element will be its correct position. Like for 5, what is the correct position? For 5 I know for 5 the correct position is index 4, right? So what I am doing, I just swap with 5 and index 4. Like for this is index 0, this is 1, 2, 3, 4, this is indexes. So I know for 5 the correct position is 4, so I just simply swap between them. What will be my current array right now? So there will be 0 and there will be 5, right? And at the 0 index I have seen that there is 0, but is 0 is a valid element? No, because my first smallest positive number is 1. So I will not take care about any number which is smaller or equal to 0, right? So I just simply go to the next number. So I have seen that next number is 4. So for 4, what is the correct position? For 4 the correct position is index 3. So I just swap with index 3. Like for that case, now my array becomes there will be 1 and there will be 4, right? But I am in index 1, but current element is now 1. But for 1, what is the right position of 1? 0. So I just simply swap 1 with 0, because I want that every element in the array which is valid, that means which can be a part of my sequence, I just swap with that element correct position. I know for 1 the correct position is 0, so I just simply swap between 1 and 0 again. Then my array looks like there is 1 and there is 0, but I am in index 1, but 0 is not valid, so I will simply move to the next element. This is 3, but what is the correct position of 3? Correct position is 2, but 3 is already in 2. I don't need to do anything. Then I just go the next element. The next element is 4. What is the correct position of 4? 3, but 4 is already is correct position. I don't need to do anything. Then I will go to the next element. The next element is 5. What is the correct position? Correct position is 4. I don't need to do anything. After that, what I will be doing, as I know that every position is in correct position, so for that case, 1 will be in 0 index, 2 will be in 1, 3 will be 2, 4 3, and 5 will be in 4 index. So what I will be doing, I know that in 0 index there will be 1, right? If 1 is present in my array. In 1 index there will be 2 if 2 is present in my array, right? But if I see that my 0 index, that is a value 1, and in my index 1 there is a value like 0 or like -1, right? And for 2 index there is a value 3. If I see that in 1 index the value is not 2, right, that means 2 is not present. How can I say 2 is not present in my array? If 2 is present in my array, then I put in index 1, right? Because in the previous case, when I'm trying to adjusting the indexes, if 2 is present, I will simply swap with index 1, right? Because and for that case I am seeing that in index 1 there is -1. That means 2 will not present in my array, right? I think this makes sense, right? So let's take another example and try to understand, and let's then go over to the coding part, right? Okay. Let's take an example like 1 5 1 2. Let's take that example. So what will be the correct position of 5? 4. But what happened if I want to swap with 4 and my n is 3, right? So this is not my valid in sequence, right? As there is 3 element, the sequence will be 1 2 3, right? So what I am saying that this is not valid element, so I'll just go the next element. What is the next element? 1. But for 1, what is the valid index? 0. So what I will be doing, I will be just swap 1 with 0 index value, right? So now my array looks like 1 5. What is my current element? My current element is 5. But what is the correct position of 5? 4. But this is greater than my array length, right? So this can't be my sequence. So then I will go the next element. For 2, what is the valid index? For 2, 1, and 1 is less than array length, right? So what I'll be doing, I'll be just swap 5 with 2, because in 1 index there is 5, right? So now my array looks like there is 2 and there is 5. Then again, what is my current element? Is 5, right? But for 5 the valid index is 4, but this is not a valid index. That means what that means? That means I have an array of 3 length and I want to swap with 4, index 4. This is not the case, right? For 3 the valid indexes are 0 and 2, right? So I have to take care of that. I think this makes sense. Okay, and now for that case, what will be my answer? In the 0 index I have seen that I see that in 0 index there is 1. That means 1 is present. In 1 index 2, the value is 2. That means 2 is present. But in 2 index, in index 2 there is 5. But for my sequence in index 2, what is the element? 3. That means 3 is not present in my array, right? So what will be the time complexity? What I am doing, I am just go through all the element and adjusting its position, right? So if that is n element, I just adjusting n element, right? So the time complexity is big of n. I am not using any space, right? I am not using any space, so the space complexity is big of 1. So my solution time complexity is big of n and space complexity is big of 1, right? Next, move to the coding part. So what I will be doing, I'll iterate over all the element in array. First we find what is the length of array. Then I will go through all the element, means for I 0 to less than n. Then what I will be doing, then I will be checking if my current element is valid or not. That means if the element is positive and this is less than my array length, like if the element is greater than 0 and less than n, that means this element is valid. And and what I will be check, and I will also check if this is not already valid. That means if nums of I not equal to nums of I minus 1, that means it is already valid, then I don't need to do anything, right? So if not the case, what I have to do, I have to swap between the position, swap the values, right? Swap the values. First I stored first I stored the value which is in nums of I minus 1 index, right? So this is the value which is in nums of I minus 1 index. Then I set nums of I minus 1 is nums of I, and then at last I set nums of I equal to 10. That means I have swapping, but I have to do this as long as this condition is valid. Why? Let's take an example. For that example, I have seen that for 5, what is the valid index? For 5, the valid index is 4, right? For 5, the valid index is 4. Then I just swap between them, and then my 5 becomes 3 and my 3 becomes 5, right? But again I have to swap because 3 is not in its correct position, right? Because for 3 the correct position is 2, right? So I have to adjust it until the condition is false. That means after that I will swap 3. After that I will swap 3 with index 2. That means at that position the value will be 3 and 2 will comes here. Then after that 2 is also is not is valid position, because for 2 the valid position is 1, but for 2, now the 2 is on index 0. So then I have to swap again with 2 for 2 and his valid position, right? For 2 the valid position is 1. Then I swap between them. Now the my 1 becomes 2, and for that case and there will be 1, right? Because I am swapping from 0 index and 1 index, and now it looks that for 1 index, what is the correct position? For 1 index the correct position is 0, and for 1 already is in 0, so the condition is false, because the condition is while nums of I not equal to nums of I minus 1. That means until my current element is not in valid position, I have to do this, right? So instead of if, I will just put an while, and this code is adjusted the all the element means all the valid element position, right? Then I have to check whether all the value is valid or not. So I will go through all the element and I will check is my current value is valid or not. If the current value is valid, I have to do nothing, but if not valid, I have to just return the first not valid value. Like for nums I, the value will be I plus 1, right? This is the valid, but if this is not the case, that means nums I not equal to I plus 1, then I simply return my current value, right? And if all the value is satisfied, then I simply return n plus 1. Why n plus 1? Let's see. If my array is 1 to 3, right? Because 1 is in 0 position, it is valid. 2 is in 1 index, this is valid. 3 in is 2 index, it is also valid. So what I have to return? I have to return 4. But 4 is nothing but n plus 1. What is n? The length of the array. For that case, it is 3 plus 1. That means 4. For that case, the answer is 4. Right? That's why I am returning n plus 1. Let's run the code. Yeah, it accepted, and let's submit it. Yeah, it beats 98%. If this video is helpful for you, make sure you like and subscribe the channel and follow for more content like this. Thank you.